Okay, I'm gonna do this last problem sideways, so hopefully it works a little bit better. Sorry for it going really fast. I'm just trying to deal with like space and uploading these up to YouTube. So here goes nothing. I'm gonna take this and I'm gonna play that LCM game. Kind of going back to what we did with expressions. N plus 8 and n plus 1 are two different things. Binomials have to look exactly the same, and there's nothing I can factor. So my lowest common multiple are both of those. So again, I'm going to write each of those things, including that one, and right behind it, I'm going to write that. So I like my setup, which just means writing this out and writing a big parentheses, writing the minus 6 over n plus 1 and a big parentheses, and writing a 1 and a big parentheses. What goes inside of there? N plus 8, n plus 1, n plus 8, n plus 1, and n plus 8, and n plus 1. Okay, so we start canceling stuff and then doing some multiplying. N plus 8's cancel. What do I have left? N plus 5 and n plus 1. There's some heavy math in there, so I'm going to hold off on that. What cancels here? The n plus 1s, so I have negative 6 times n plus 8. And then what's there? 1 times that, which is just n plus 8 times n plus 1. I can even write that 1, but at the end of the day, it's not going to make a difference. So now I got to do a bunch of multiplying. That one's probably the easiest one, which is distributive property, but these could be either that FOIL or distributive property that I taught you. You could even do box method, where I'd write n plus 5 on the top and n plus 1 on the bottom. Most traditional math teachers are probably going to do a bunch of distributive property and FOIL. So I'm going to show you that and see how that works for you. N times n squared, n times 1, 1n, 5 times n, 5n, 5 times 1, 5. That's all that. Here I'm going to distribute negative 6 to each of those, paying attention to that negative. So negative 6 times n is negative 6n. Negative 6 times 8 is negative 48. Otro lado, here we go. 1 doesn't make a difference. If there was any other number, I can multiply it in first, but only to one of them. Usually what I'll do no matter what is I'll multiply the ugliness. So again, ignore the 1 just because it's 1, but n times n, n squared, n times 1, 1n, 8 times n, 8n, 8 times 1, 8. Now it's a bunch of combining like terms. N squared is my highest power. 1n plus 5n is 6n minus 6n. All of that cancels. Well, again, 1n plus 5n is 6n minus 6n, gone. 5 minus 48, negative 43. Other side says n squared. 1n plus 8n is 9n. And then plus 8. What I'm going to do is move everything to the other side. I'm thinking I'm going to move all that over there because this stuff looks smaller than that, even though 43 is big. Minus n squared, minus n squared. Add 43 under the 8. All that cancels and I get 0. Those cancel and I get 9n. 8 plus 43 is 51. I give you a bunch of ugly looking things. At this point in time, you just solve a two-step equation. And I get negative 51 is equal to 9n divided by 9. And while 9 does not go into 51, you could divide the top and bottom by 3. Negative 17 over 3 is equal to n. As ugly as that looks, I just look at the top. That's not going to set any of those off. The answers that set that off, in other words, make the denominator equal to 0, are negative 1 and negative 8. Your teacher is going to show you if one of these answers came out to negative 1 or negative 8, you would cross it out. And if you had no answers, you'd say no solution. There's a whole lot more to these problems. Some of these you may end up not having those n squareds cancel and have a quadratic. With that quadratic, maybe you factor and you set them equal to 0. Maybe you do one of the last things that I taught you, which is quadratic formula. This is a start. Hopefully it helps you out. Best.